Okay, so today we're going to continue on with enthalpies of formation. So remember, we're looking at delta H of F. Okay, and what is enthalpy of formation? It's the reaction to produce a chemical or a substance from its elements in their elemental form. Okay, so that's what delta H of formation is. We're getting an element or compound from elements in their elemental form. Sorry, 1 mole. Okay, so let's produce 1 mole of a substance from its elements in its elemental forms. Now, as we've seen with Hess's law, similar stuff with enthalpy, we know that enthalpy is a state function. Okay, so a state function means, of course, again, it's not path dependent. So all that matters is where I start and where I end. The nice thing with that is it's going to gives rise to this new equation that the change in enthalpy for a reaction, Rxn, okay, any reaction, is equal to the summation of the change of enthalpies of formation, okay, of the products minus summation of the change in enthalpies of the reactants. Okay. So since enthalpy is a state function, we can go ahead and use that. If I know the delta H of formations, okay, for all of my products and all my reactants, I can find the overall change for the reaction. So let's take a quick look at that real quick. All right. So let's take a look at the reaction here. So we got 2 moles of aluminum plus iron oxide goes to aluminum oxide plus 2 moles of F. Okay, and I want to find out what's the delta H for this reaction. So we've looked at a couple different ways you could do this. You could do this reaction in a calorimeter. This one you couldn't because this is iron thermite reaction and it would melt through the calorimeter. But let's pretend like you could do it in a calorimeter. You could measure the heat somehow. You could look at some different reactions using Hess's law to add up to this overall reaction. Or we can look at the delta H of formations for each of these individual compounds. All right? So first off, the delta H of formation for, and I'll just write them up. Here, let me do this. Set this up a little better. Let's do the delta H of formations right under here. So aluminum in its elemental form, its delta H of formation is 0 kilojoules per mole. Why do I know that? That's our 0 state. Remember, that's our reference. We're going to say elements have a delta H of formation of 0. Okay? The delta H of formation for iron 3 oxide is negative 826 kilojoules per mole. Aluminum oxide is negative 1676 kilojoules per mole. And then again, we have iron in its elemental form, so this is going to be 0 kilojoules per mole. Okay? And if we remember, all these delta H of F's are found in tables. Okay, so these are references that we looked up or can look up. All right, so now we just plug them into this formula. So it's equal to the summation of negative 1676 kilojoules. And I have 1 mole, so I'm going to multiply this by 1. So it's just kilojoules. Plus 2 times 0, so 0 kilojoules. Minus the summation of 2 times 0 again, so 0 kilojoules for aluminum. Plus a negative 826 kilojoules per mole. Sorry, kilojoules. Because I have 1 mole of this, so I'd multiply 826 times 1. Okay? So then we just get that. So we add those up, and I have negative 1,676 minus a negative 826. And what I get is a negative 850 kilojoules. Okay. So that's the change in enthalpy. So for this reaction, is this reaction endothermic or exothermic? Well, my delta H is negative. Okay, therefore, I know that the reaction is exothermic, and it produces heat. This reaction is extremely exothermic, iron thermite reaction. It will melt through metal. The iron's it's so exothermic that this is normally molten when it's made. So yeah, this is an exothermic reaction plus heat. Okay, the energy difference in the products to reactants is coming out as heat. So this is kind of the final way we can find delta H of F for reactions. Okay, so we can use this equation here. So the delta H reaction is equal to the summation of the delta H of formations of the products minus the summation of the delta H redo that one. Delta H of formation of the reactants. All right. Hope you guys have a good day. Don't forget to like, subscribe. Get this ad revenue going for me here. My retirement plan from school. Have a great day, guys.